hit record. Turn off my alarm. And greetings and welcome to our first webinar for the 2024 total solar eclipse for our Texas Master Naturalist Eclipse Educators. I'm super stoked to see so many of you back, and we will get going here. I've got a fabulous guest speaker, Dr. Carolyn Ng. I had sent earlier her bio, so you know a little bit about her. I also want to say I've had the pleasure of working with Carolyn for at least 3 decades as we have interacted both when I was a classroom teacher and she would support all the work that I was doing in the classroom. And then later when I got started working over at Goddard Space Flight Center in summers doing some extra work with Helio. So it is my great pleasure and such an honor to have Dr. Carolyn Ng joining us today. And Carolyn, I will let you go ahead and I'll keep admitting people.
Thank you so much, Dorian. Good morning, everyone. What a pleasure to work with you and chat a little bit about the upcoming eclipse. So again, my name is Carolyn Ng, and I work at NASA Goddard Space Flight Center as an employee of AdNet Systems with a fabulous team that focuses on education within the Heliophysics Science Division. So the study of the sun and how it interacts with Earth and the entire solar system. So what inspires you? I know you are naturalists who like to interact with communities and excite them about the nature, right? So for me growing up, I was fascinated by the Apollo program. And very soon, the Artemis program will send the first woman and the next man to the moon. But to protect our spacecraft and these astronauts, we must study one big object that generates space weather in space. So what can that be? It's the sun. A quick review.
I'm going to jump in 1 minute. I don't think you are in presentation mode.
Oh, I'm so sorry.
Okay. No worries. You can't know when you're sitting there and you can't see it.
Yeah.
I'll let you know when I see that we are.
Okay. So what slides are you seeing?
We're seeing, how do you know about the sun on the left, and then kind of like how you can switch it over, and then your kind of notes down on the bottom on the right.
Yeah. Okay. So let me exit.
No worries at all.
I apologize.
All good.
So,
and for those of you who have just lit in the waiting room, we've got Dr. Carolyn Ng from Goddard Space Flight Center, and she is presenting to us today.
I am going to use one screen, so that will not distract us.
Cool.
How about that?
Yep, no worries. I always feel like I'm the Wizard of Oz, pulling things and can't quite see what's going on when I present, so I get it.
Okay.
And I hope, as I'm looking in the chat while we wait for this pictures to come up, I'm seeing that that many of you are cold now in Texas. Oh, there you go, Carolyn. Perfect. All right, carry on as you were.
Yes. Okay. So you probably know a little bit about the sun, right? What is it? It's really a star. And how big? It's so big that 1 million Earths can fit inside the sun. And how far is it? It's 150 million kilometers, or for Americans, it's 93 million miles away from Earth. So it's pretty far, but it's still the closest star to us. And what is it made of? It's all gas, but the gas is so hot that it actually turns into plasma, an electrically charged type of matter. Here is an image of the sun one image, invisible light, and you can see dots on the surface. And those are sunspots. And sunspots are very electrically charged. They are active regions where plasma will follow the magnetic field line. So enjoy this image from the Solar Dynamics Observatory AIA instrument. See all the activities on the surface of the sun. The changes happen by the minutes, by the hour. Here is another close-up view of the active region. Why I'm showing you all these is because on the day of the eclipse, with a telescope, you may see something like this. Not this close up, but you will see something from the limb of the sun. Those are the beautiful images, right? But there is also some impact on Earth caused by the sun, because occasionally the sunspot will be so intense and so big that it will burst like a volcanic eruption, sending hot matters, the plasma towards Earth. But fortunately, we have protection from both the atmosphere and the magnetic field. You see, these hot matters follow the field line, and then sometimes so following the magnetic field line and stream into the borealis. So that's the beautiful side of space weather, giving us auroras in the night sky. But there are also other effects that will affect our technology. So you see streaming into the pole and creating the auroras. So the sun is the main source of our space weather. And then we have teams at Goddard that actually do the forecast. And NOAA will give the National Weather Service, including space weather forecasts, to help protect all the access and human lives on the moon, to Mars and beyond throughout the whole solar system. So continuing to talk about the moon, because it takes both the sun and the moon and Earth to cause an eclipse, right? So what is the moon? The moon is really a chunk of rock that scientists think broke off from Earth. It is not that big. It circles around the Earth, about quarter size, but it's bigger than Pluto and is quite close to Earth and only 30 Earths away. It's mostly made of rocks and oxygen and some other materials. So now putting it together, if the sun is very big and the moon is kind of small, smaller than Earth, how can the moon block the sun and appear the same size in the sky? The moon is only a fourth the size, right? But it's so close to Earth. This is what they call the apparent size. And this image is where it happens when they are perfectly lined up. The blue line represents the moon, and the sun is behind it. And then you can see the sun's atmosphere, and that's what we call the corona, the crown. It's a thin layer that extends beyond the sun and throughout the entire solar system. Because the sun is so close to us, it's the only star that we can see during the daytime. So a solar eclipse is about shadow. When the moon passes between the sun and Earth, the shadow casts on the Earth, blocking the face of the sun. So we can only see faint light coming out of the sun. And for you, if you are in Texas along the path of totality, you can actually see total blockage of the sun. So there are big shadows and little shadows because the sun casts sunlight all over, but when the moon is directly in its path, then it will focus, and that's the umbra. And then there will be other light that will see fuzzy shadow, and that's the penumbra. But everyone else will see a partial eclipse, right? In the penumbra. And those in the umbra, they will see phases of the partial eclipse until the moments of totality. And depending on your location, whether in San Antonio or Austin, part of Dallas, you will see a few minutes of totality. How many saw the annular eclipse back in October? Yay! I was lucky. I also traveled to Albuquerque. That was my first annular eclipse. So even when the sun and the moon and earth totally line up, the moon is not big enough in this apparent size, right, to block the entire sun, leaving a ring of fire or the ring of light. And this happens because the orbit of the moon is not always the same. Sometimes it's closer to Earth and sometimes it's a little further. Can you see the, sorry, I have to open a different frame here. So that's why, have you heard of the supermoon? It's okay. Because when the moon orbits are closer to okay, I will leave this animation for you to enjoy later.
No
Let's
worries.
go back to this. So at some
Terra
point,
is an all-in-one IT
oh,
platform
I'm so
that prevents
sorry.
problems before they happen.
Oops,
IT
oops,
problems.
All righty then. And as Carolyn's waiting to come back up here, this recording and all of the slides will be shared. All of it will be available in Basecamp. So sorry about technical difficulties, but I'm sure all of you who have messed around with presenting virtually have experienced this. Technology giveth and then it taketh away. And Carolyn, if it's possible to turn your VPN off, it might be a little smoother, but you see what works best for you. I've turned mine off.
Ah, good point. Okay, I'm back. So because the elliptic orbits, sometimes the moon appears to be closer to Earth, and then sometimes it's further away. When it's further away, then it does not completely block our view from the sun and creating that ring of light as it happened in the October annular eclipse. And then why won't we see an eclipse every month? This is another interesting one. I don't know if you have played with hula hoop around your waist. Sometimes it's perfectly parallel to the ground, right? Right around your waist. But sometimes the hoop will be up and down at an angle. So that the hoop actually mimics the orbit of the moon around Earth. And it's tilted at 5 degrees. And that's why we have season. This is another, I will stop playing the animation and let you find the video online. Because when the tilt is above the plane of the ecliptic, then we will not see a perfect alignment, and you will see only a partial eclipse and not a total eclipse, or sometimes completely miss it. So here are the three types of eclipses. The middle one is what we experienced last October along the path, but everybody has seen partial, weather permitting, both in October and again in April, hopefully. And those on the path of totality will see 100% blockage of the sun. So we are very fortunate to have two eclipses in the United States within such a short time, because eclipses are not rare, but the Earth is 70% covered by water. So you have to travel far to see it, including in the Antarctica a few years ago, or Norway. I was lucky enough to see it in Turkey, China, and then in Carbondale, Illinois in 2017. So I'm very excited to be able to see it in 2024 here in the United States without traveling far. If you miss it, as Dorian said, the next one will be 2044, and only clipping the northern part of United States and Canada. 2045 will have a path again from the West Coast to the East, but you have to wait 20 some years, right? So take advantage of it. Here is the map, and I see it on the background of Dorian. You see the whole country, at least the 48 states, will see the April 24 eclipse. Hawaii may see a little bit, but not a whole lot. So Texans, you are really fortunate along the path. You will see it first before our friends in the north, in Maine and Canada. So how did you observe the October 14 eclipse? Or how will you prepare to observe the April 8th eclipse? Would you like to type in the chat room? And Dorian, you can help us out if there is any answer.
Yep, there's all kinds. So let's see. We have here, I did with glasses during the annular, and then I'll take my glasses off during totality, and then, put them back on. Solar eclipse glasses. Someone is near the edge of the path and is going to watch from their backyard. Glasses and a filter for their phone. Use the American Paper Optics glasses and a flat viewer. And then we're lucky enough to watch from their backyard. So we heard about both place and then also, safety. So yeah, lots of
Wonderful.
Yep.
Wonderful. Yes, safety is number one, right? We want everybody to enjoy the eclipse, but also be safe. Please remind people, don't use the regular sunglasses, and don't look up without protection, whether it's viewer or the glasses, and make sure they meet the ISO standard 12312-2, the international standard. Before and after each use, make sure you also check to make sure there are no scratches, detachment, or damages. And if there are, then discard them. Yeah. Instead of calling them solar viewing glasses, I would like to remind people that they are not just for eclipses, right? You can save them beyond the April 8th and use them to watch the sun at all times, because you may be able to see large sunspots. I cheated a little bit. On the left actually is a telescopic view from the ground, but with a large group of sunspots, you may be able to see them with solar viewing glasses. I also posted a couple of images on top with children decorating their glasses. And there is one activity using paper plate. So you can make it both stylish and safe for your fellow observers. Okay, so someone mentioned how and when to put on the glasses and when to take them off. The only time you can take them off is during totality, right? Before and after, you must have this protection. 99.9% is still not 100% blockage, and so you must wear the glasses or the viewer. What about those who don't have glasses? No problem. You can use pinhole projection method, right? On the left is a video how to make a pinhole box. It's fun. And NASA actually is translating that into different languages, including Spanish, Arabic, and other languages. On the right, you can find a colander from your kitchen and then project that, or just stand under a tree, right? Or use your hand and form a grid. What other projection methods have you tried? Could you type in your chat room?
And I see some, we had a wonderful tree leaf filter at the River Ranch. We also made holes in paper.
Uh-huh.
I know I've seen, of course, and we tried where we were using a colander and this punch project. Well, you can't see it very well because of my funny thing, but
Yes.
the projector.
Uh-huh.
And I put up on our base camp lots of cool ideas that Lynn Travis had. So yeah,
Nice.
all kinds of good stuff.
Good. Actually, I'm glad Dorian said the punch pinhole projector. Yes, it has 3 holes with different shapes, right? And you can make a prediction and play with that leading up to the day of the eclipse, and then use it to cast the partial eclipse on the floor or on a white piece of paper. We also have a pinhole projector in the shape of US map, and that resource, along with some classroom activity, is available online. I have an active link here, but if you type in, I can share that with Dorian afterwards, so you can post it online as well. So the classroom activity also has an extension for math, doing a simple ratio for 5th grader. So this pinhole projector in the shape of the US map can be printed, 3D printed, or using Cricut to do a 2D printing, or you can simply use a pair of scissors and cut out on a piece of heavier paper, cardstock. Then it double up as showing the map as with the paths, as well as punching holes manually. It's a lot of fun asking people, to punch a hole in the area they come from, and then cast a shadow on the floor. Okay, there are more resources, and NASA has a Spanish website. There are social media coverage, live shots, and then the safety flyer that I show on the right-hand side is already in Spanish, but again, it will be translated into more languages, the common languages recommended by U.S. Census Bureau to us, and several resources will be available in those languages shortly. And French as well, because we are partnering with our Canadian colleagues in northeastern part of the country. So why do we study eclipse? Why does NASA get involved? Because we do learn from solar eclipses. Turns out the sun has seasons, much like Earth. Earth has the 4 seasons. The sun has a longer cycle of 11 years. Every 11 years, the sun becomes more active. On the left, you see a quiet sun, like a balmy summer day with little wind. And then on the right is a pretty angry sun, like a hurricane season or like a snow blizzard, you know. And there are a lot of activities going on. These are images again from the Solar Dynamics Observatory showing the cycles. So every 11 years, the sun becomes very active and the magnetic field actually flipped. The North Pole became the South and the South became the North. And then all the magnetic field line got tangled up, right? So we are actually about at the solar maximum, and it makes it very exciting when the eclipse will fall during this active time of the sun. It's an opportunity for us to learn more about the sun. And heliophysics, again, is the study of our sun, how it behaves and how it affects life on Earth, as well as on other planets and throughout the entire solar system. What you will see during the totality, I got very excited closer to the moment when the sun is completely blocked. That's when you start seeing very faint solar wind coming out of the atmosphere of the sun. And there will be Bailey beads. There are sunlight shining through the gaps on the moon's moonscape, right before the totality. And then they will all gather into one light, one last bit of light. And that's what we call the diamond ring effect. And then sometimes you'll see prominences, like at the 3 o'clock, 4 o'clock, and the 6 o'clock. You see bright structures dangling over the limb. And they are like the slinky, right? The active regions. But if they happen on the disk of the sun, they're actually called filaments. So these are features that we can actually identify only during a total solar eclipse with naked eyes. What else can we learn from the solar eclipse? Actually, there is a layer of the atmosphere that affects our communication, radio communication. The signals passing through the atmosphere is affected during nighttime, but when the eclipse happens, our atmosphere actually experiences a rapid change from day into night. And so there may be some disruption of signals, and also our satellites are flying through that layer of the atmosphere. And so there will be teams studying the changes, the abrupt changes in that atmospheric layer called ionosphere. So how can you get involved? NASA will actually have 12 teams, actually maybe more. We know there are more, but officially there are 12 teams along the path. And many are in Texas, from Kerrville to Stonewall, Austin, Waco, Dallas, and then moving up the Ohio Valley and into the New England area. So you can get involved and volunteer your services to help NASA teams. Maybe do some activities like decorating the glasses and make them both safe and stylish. You can also explore with the pinhole projection, because the whole process takes about an hour and a half. And totality is only a few minutes at best, right? So what do you do for the rest of the time? Pinhole projection will be one great way to look at the changes, the progression. Another activity is called predicting the corona. We are almost, we updated the activity, and so I didn't show you during this presentation. But basically, we want people to guess what the corona, the sun's atmosphere will look like using chalk on a dark piece of paper. Now, the corona actually won't look exactly the same from one eclipse to the next because of the solar cycle. When the sun is less active, the solar wind will point in one particular direction. But when the sun is very active, it will go in all directions. So artists, you can really play with chalk arts and see how close you are to the day of the eclipse, right? And then finally, there is an all-time favorite activity of mine is playing with UV sensitive beads. And Dorian, you must have lots of those, right? They are sensitive to UV light, so they are like our UV detectors. When they are indoor, they can be colorless, but when you step outside into a natural sunlight, they will change colors. And then you bring them back in. You can experiment with underwater, using sunscreen or under a piece of plastic and see how they react, to different shields, sun shields. So that's another activity you can play with. Or you can get involved with citizen science projects. You probably have already heard of or get involved with the Globe Observer, right? Or the soundscapes and learn about the changing environment during totality. When I was in Carbondale, I really can get a sense of the sounds and the sights all around me. So don't just look up with the solar glasses, also look around you and look down and get a sense. So eclipse soundscapes have different ways to get involved. You can take data, or you can analyze data, or you can be an observer and help record. So there are many roles to play. And then there is another project, a favorite of mine. It takes a little more training, but you can invite the project scientist to give you a talk later. It's not just for the eclipse, it's at all time. When you can see a sun depicted by a white line circle in the middle, and an artificial eclipse with a blockage around it. So you can see the bright light of the sun going around, right? The corona. Now comes some comets, one on the upper left. This sun grazer project actually helped scientists discover close to 5,000 comets. So eclipse, the natural eclipse occurs once every year, every other year, but artificial eclipses happen all the time with our technology in space, and that's the SOHO satellite. And comets are grazing the sun, and now we are combining the two technologies, and keep discovering. So there are more citizen science projects that you can explore. I won't name all of them, but Radio Jove is another fun one you can do year-round, including in quiet places in the park. You can learn more. There will be training slides available in early February, and that will be available especially the NASA workforce, but will be shared through the Oregon State University. So you can download the entire slide deck and you can present to your users. There will be some more training activities, especially with the ones that I mentioned and more. Like the yardstick experiment, our partner will be part of that training. So Dorian will have the schedule and she will alert you. I will stop right here. All the resources I mentioned actually are on the Eclipse website at NASA. So back to you, Dorian.
Wow, Carolyn, that was really, really just you covered the entire spectrum, from what the sun and the moon kind of are, and then how they interact with each other, why NASA is studying that, what we can anticipate, seeing, knowing the physical processes that are taking place. It's a lot to take in. And I'm so glad we're getting this opportunity, especially in Texas, to be able to have had a trial with the annular, and now kind of getting in there big time, with the total eclipse. And for those of us who observed the annular, I know I had the privilege of being at El Suaz Ranch, and of course it was cloudy, we were like, oh man, are we going to see it? But we were still had so much to do, having a great time. Lynn Travis had all these great activities that we could interact with, and then the clouds kept parting, and we could start to see the moon starting to make its way along the limb of the sun. And then during annularity, the skies cleared over us. It was crazy. And we got to really, see what it looked like. We could actually see with our glasses on, of course. And so funny, I just happen to have mine right here. With our glasses on, we could see when it was covering it, and the ring of fire. But man, as cool as that was, and that was incredibly cool. No one will say an annular eclipse isn't. But wait till the total eclipse. I, like Carolyn, had the great privilege of observing the total eclipse, or the eclipse in totality at a minor league baseball game. I was helping with a NASA event, and it was astounding. So I do hope, if you're not directly on the path, you will do whatever it takes to get yourself on the path. And I'm going to show you in just a minute here. I'll stop and see if anyone though has questions for Carolyn before I stop and show you what I've got now for our base camp. So I see that you're getting thank yous, and I really wanted Dr. Ng to get a feel for just this amazing group, because she, as she says, she does a lot of work and leads a lot of these outreach activities that are going to be taking place in those various locations. And truly, if any of you would like to be a part of any of the upcoming NASA events, I will get the list from her and make sure you have that. And then you have her email, and I'll remind you. You can reach out. And if you're in the area, you might even do some things ahead of time to get people knowing about it, and then advertise it. And then, should it fit in your schedule and in what you want to do, you'd be welcome to be there during the eclipse. And of course, after the eclipse is also kind of a cool time with a group of people who had that experience, or at least around it, to maybe do a library program or something like that, and just kind of share some of the things you learn from it. And then also have people leverage the information that you're master naturalists, and you do so many things in the realm of the work that you do as master naturalist. So it's a great time to kind of share what you're doing, whether it's related to the eclipse or outside of the eclipse. So lots of thank yous coming your way, Carolyn, and I wholeheartedly agree. We were incredibly privileged to have you. And I hope that when you get a chance, I'm sure you will send me your slides, and then I will be putting them up on our base camp. So that's what I'm just going to take a few minutes to remind people about now. All of you master naturalists have access to this base camp, and this is going to primarily be our one-stop shopping. I will update the story map, and that'll kind of be an online textbook. But the nice thing about base camp is that it is collaborative. And so as we get in here, I'll take you and show you docs and files, because I've done a little bit of changing up in here. When you're looking for information, or when you've created something, I hope you'll feel free to get in here and share your stuff too. Hence the collaborative. I put a lot of the things we were working with for the annular eclipse in this October 14th file. Over here, I've started a folder for, let me come back here to this, for ideas of things you can do before, during, and after. And then I made a separate thing up for like crafts and fun. So let me go in here and show you. These were all these really creative things that Lynn Travis, one of your master naturalists, had come up with. So if you're wondering, what are some things that I can do before, during, after the eclipse, to have some fun with it? Here are some examples here, and feel free to add to that. Carolyn was also talking about some activities. I can add them. I can just come over here and say new, and I could upload a file, like with the information, say, about that American pinhole, viewer. Once I go and find that, I can upload that here, so that you kind of have some one-stop shopping for some crafts and fun things you can do. Over here for before, I thought I'd go ahead and model. You can do this in any way you feel like it. If you like, you could come over here and, well, let me just show you here. These are some activities that I'm going to be doing. So I thought I'd put them up here, and I'd also put links so that anything that I'm doing, I'll share with you. And that way, should it be something you hadn't thought about doing, but you're like, oh, that would be cool. Imitation is the sincerest form of flattery. So for a couple of you, I'm going to be giving virtual presentations such as this, kind of covering the basics of what a solar eclipse is, maybe compare and contrast with the annular, talk about the safety, and show them some resources. And of course, I'm also going to sing the praises for the Texas Master Naturalists as I interact with them. If any of you would like a speaker, just reach out to me and let me know. I'm happy to do it, as long as I can fit you in my busy schedule, but I do love doing it, so no worries. Then I'm going to be teaching an in-person class for 4 sessions for my local Montgomery College Lifelong Learner Institute. And I'm going to do one that's going to be focused on the sun, and then another day, a 2-hour session on the moon. And I'll have like hands-on fun activities that we'll do together, also teaching them about those 2 objects. And then we'll look at the Earth, and then they'll actually come out to NASA, and I'll bring in a couple of speakers who can talk with them there, and also talk about the eclipse. And then I've got an in-person library program. So like I say, if you want to get some ideas, you can take a look at what I'm up to. But I'd also love if any of you have things you're doing, you just come over here and you push new. You can start a new doc or make a new folder. For that one over there, that's just a doc. You could do a folder if you wanted to do, like if you wanted to add pictures or things like that. And don't worry, with this sort of thing, you don't really mess it up. Like, let me come back here. And you see how nothing happened? I can get started with that. And then if I even did this and I wanted to erase it, I'd come to those 3 dots, and I can move it. I can do I can, put it in the trash. So get in here and play with this. You're not going to break anything. It's really, I just love this as a collaborative site. So we've got that stuff there, our crafts and fun. Multimedia resources, I've really cleaned this up. And so the things Carolyn was talking about, you're going to find here. This is kind of like your one-stop shopping to get in there and look at everything eclipse related, but including some of those cool projects. These are NASA eclipse related pages. Here are Globe Observer related pages. And then these are kind of like a little bit of other things that are really cool. This one here, someone just shared in an eclipse meeting that I had yesterday. And they went and they took pretty much everything and they collaborated it collated it really nicely. So just all kinds of stuff. Anything that is up here is free for you to use. We want them used, and we don't have they're all, you can just credit NASA, our Globe Observer, and you're welcome to use them. So there's what I have there. Story map, if you're ever wondering, how do I get to that darn story map? What was that link? I just leave it right in there. I haven't updated it yet for the total eclipse. I will. This thing seemed to me more important. And finally, this is promotional resources. Here's like an example. If you make any promotional resources for sharing with your community, please feel free to add them over here, because that way we learn from each other. And, if you want, you can even make it so that other people can get in there and modify it, so that way we're not all having to kind of create the wheel. So I'm going to stop there, and I'm going to go to the chat now and see if I can open the chat. Okay. if I have questions about this, or feel free now, you can unmute if you can do that. Oh, man, you're just seeing me and not the base. Oh, okay, cool. After I talk into air like this. So if anyone has any questions about Basecamp, again, I'd love it to be collaborative, love you to get in there and add stuff. You can't break it. If you have any specific questions and want me to kind of go through or answer questions or help you out, email me. I'm always more than happy to. Yes, I sure can. Absolutely. And copy. And something I'd mentioned before, if you have any other master naturalists who would like to join, I had somebody reach out to me last night. Please have them reach out to me, to let them know that this has been approved by the Texas Master Naturalist. They can get hours. I guess they have to talk to their local chapter to head to know how they can get hours. But you can get hours for attending the webinars and for the interaction, the engagement activities that you're doing before, after, and during the eclipse. So I'm
Could,
just
could I could I ask Dr. Ng's presentation? I thought was so comprehensive in such a short amount of time, and it had all the safety and all the fun. I don't know how you did that in 20 minutes. It was fantastic. Where is that presentation something we could use, Dr. Ng?
Yes, you can take and run with it. Yeah.
Okay, so Doreen, is that something that you'd put on Basecamp?
I certainly will. And so I'll put it in two places and that's a really good question. I'm always going to put the recording and the slides where you have the schedule in Basecamp. It says schedule. So what, that if you're thinking, oh, where was that? Because that to me is kind of like a logical place.
Mm-hmm.
But then I'll also, I'm just looking here to see in my docs and files, I may make a new slide. I'll make a new folder called presentations. And that way you can go in there. They haven't yet released the presentation that has kind of the NASA slides, but they will soon.
But these were the heliophysics.
That's right. So I will put those in once we get them, but I'll also put, thank you very much, Carolyn, for being willing to share it. Just makes it.
It was just really comprehensive and short. And like I say, it covered the facts, the fun, the safety. I think it's a great base.
Perfect. Yep. We'll get those slides and share them because this is exactly what we want. We want this to just be shared out and not to make life any more difficult for you. But to make it easier as you start to kind of let people know, hey, the hype is real.
Well, it's 2024 now too.
Yes. Now someone has a question here. I know it happened so fast. How to order the punch cards. I have been trying to get some of these things ordered for, to hand out to some people. I have run into kind of a brick wall in trying to get mass copies. Maybe Carolyn could speak to that, but I'm meanwhile going to look at this punch card and I'll put what it says the information is in the file here, and I'll also add that in the resources.
On the punch cards, Dorian, I had like no problem getting a lot of them for the conference. So maybe I can send you the contact that helped me. Now they may have run out of them since then, but I said, she's like, how many do you need? And I gave her a mediumly high number. And I said, if that's too much, I understand. She's like, we've got a warehouse full of them. So it may be getting to the right person.
I think that is absolutely true because we run into this, and Carolyn Carolyn knows what it's like, where sometimes you just have to know the right person.
Yeah. So I'll send you who I talked to.
Excellent. Sherilyn Morrow is the solar scientist and who is the director of the communications and public engagement. But I'll give you a tip. That group is based in San Antonio, Texas. So for the day of the eclipse, the lead person, slipped my mind. I can picture. Crick DeForest, Dr. Crick DeForest is leading the entire project. He will be personally in San Antonio.
Cool. Okay, so these are
and the punch card, that kind of egg-shaped punch card, is in Spanish also.
Yes.
Nice. Very, very good. Yeah, I know when I go to some meetings, there'll be a table full of things, but often I'm traveling with a suitcase and I can't grab. So yes, I will find Cheryl Morrow's email information, and I will make a thing too of contacts, you know, so we kind of have contacts in one of our folders there. Excellent, excellent question. And I'm going to go ahead and I'm going to stop the recording if I can figure that out.